Hello, and thank you for joining us for Autodesk's latest webinar with Car Design News. I'm Owen Reedy, the editor of CDN. Today we're focusing on Autodesk Alias Automotive, the advanced sketching, modelling and visualisation tool. We'll be joined by Barry Kimball as he demonstrates modelling workflows and hints and tips for rapid surface modification using the dynamic shape modelling tools. Barry's part of the Alias team supporting OEMs and suppliers in the Greater Detroit area. He's a Class 8 surface expert with extensive experience gained from working with Nissan, Ford and GM. And I believe he's actually going to give us a little background about himself as he starts his presentation. As he goes through the presentations, please do ask any questions you'd like him to answer during the Q&A session at the end. You can ask these by typing them into the box on the bottom right-hand side of your screen. You can also use the same box if you experience any technical issues. I'm sure we're in for a very interesting presentation. It's now time to hand over to you, Barry, so you can begin your presentation. Thank you.
Okay, thanks, Owen. So today we're going to be presenting some dynamic shape modeling tools for, in between concept modeling and Class A surfacing, I would say, is going to be our target. So I'm just going to start moving along because I think we have enough material to cover the whole hour, so I'd rather have extra time for questions and answers. So a little bit of background about myself I would like to give, just so you people can understand kind of my background, where I come from, not where I live, but where my ideas come from, where I've worked, and some projects I've done. Also, this is me, just so you can put a face to a name or a face to a voice. So while we're talking here, this is just some things that I've worked on here. We don't need to worry about my general resume, but previously I worked for Alias Wavefront, and I traveled quite extensively, I guess, around the world, doing product demonstrations and sales and training. I worked for a while inside Ford. I was working for myself. The Ford GT was one of the projects that I worked on while I was there. And this just kind of shows some highlighting and some patch structure things, some more patch structure things. I'm just going to go through these quickly so that I don't want to take too much time with this. Just some training material, some surface layout work. And this is a show car that I had built in 2003 when I started working at Nissan. And actually, interesting to note, a little bit of this is we'll be working on this quarter panel right here, one of the demos. A concept truck, so this was surfaced from scan data. I worked on this with one other guy. An Allure show car. I did this surface work from a scan. Nice patch layout, not perfect Class A surface, but really nice and smooth. I did a lot of renderings and things with that. About 70 hours, 75 hours to surface this from scan data, just I guess as a reference. Forum concept, another surface model. I'm trying to show these just to show the surface layout. These are all, I would say, surfaced in kind of a Class A surface layout manner. They very nice patch structure, all work together. This was 3 of us working on this, so when everybody works to the same kind of method, it's easier to work together. This is a production van. Front end, I did this front end facelift on the Maxima. Actually, we'll be talking, I think I didn't include that in one of the demos, not that front end. It was a different front end, the Allure. This Nissan wheel and some miscellaneous work. I happened to get an opportunity to do some work at NASA. Surface from scan. This was about 70 hours worth of work surfacing to this scan. This was for a race car. Did a lot of work on this race car, the hood, some ground effects, a lot of the aero stuff inside the car. Surfaced this motorcycle from a scan. You can see the scan here in the background. And then I've done a lot of training, a lot of presentations like this over the years. I've probably been working in the field for, 20 years. So I've just had some nice opportunities to be able to make some presentations like this. So I thank Owen and Car Design News, and let's just get started. So this is a quarter panel, and what I'm going to show are the ways I use dynamic shape modeling. There are a lot of functions inside the dynamic shape modeling tool set. Transformer rig, lattice rig, twist rig, bend, conform. All of these have their own individual methods that they use to modify data. I'm really going to be using the transformer rig. I'm not going to be demonstrating any of the other features. I myself don't use them in the way that I model. So this quarter panel, what can happen a lot of times on panels like this, they want to, in the side view, change this shape. So in this case, there was a late request after we had a lot of the surface work done to change from the red to the green. So if we use maybe the squishy view and just rotate this. So we wanted to take and basically extend and just change the amount of crown on the roof. Well, there was a lot of work done to this panel to get this surface made to have nice highlights through here, and to have those highlights lead into, and I just would like to show a little bit of this, to lead into the other surface. So a lot of custom tuning was done when I originally made this patch to get these highlights to look the same. So now I need to basically move this patch back to here. Well, there's a few ways to do it, and I'd like to show one way that maybe a lot of people use. Once I create a model, I like to try to reuse the data if possible. That's where you can use align or extend or different tools that allow you to modify an existing surface instead of creating a surface from scratch. So one way we could get this surface to move back here is to grab this edge, align it to this edge. I'm going to go to edge control, just G0, partial. Okay, so that's now moved from the red to the green, right? Now I need it to take all of his friends along so that it's moving the whole surface, because I like the existing surface's shape. So I'm going to turn blending on and maybe ask it to move all these rows. Okay, so it's done that, and it's kind of done it's done a pretty good job, I guess. It's got decent highlights, but in the side view, it's now higher. It just found its own way over. So you can start moving CVs and sliding things around. But what I'd like to show is a different way to do that, to make this patch respect the green patch instead of the red, and bring along all the hand tuning and all the massaging I've done to that surface. Just move it backwards. That's where I think a good use of the transformer rig is. So I'm going to modify this surface. I'll accept that as the target. Okay. The method I like to use 99% of the time is a predefined modifier, and I'll explain what that is. I'm basically telling the surface, or whatever data is underneath, it could be curves, it could be scan, to move based on a before and after shape of surface. So I would like a predefined modeler. I want to use this surface, accept that as the origin, move everything relative to that surface, except the destination. So a way to visualize this is inside the tool set here, you can turn on the sampling and diagnostics and draw this sampling. So this is showing you the start point and how it's going to move to get to the new surface. So it's basically going to stretch all this data progressively, just like these lines show. Okay, so if I say go, it's now taken that surface and modified it in I don't want to say a view, but just in 3 dimensions to whatever that new shape is. So now if we untemplate this guy, and I'm just going to move it forward in car so we can see both at the same time. Now we've got really similar surfaces, right? All the hand tuning I did to this surface now has just been transferred over to this surface. Now, a lot of people might say, well, okay, why don't we just transfer everything? So just grab this whole car, you know, and transfer everything. You could do that. The results will be something that needs to be rebuilt. You know, all of the fillets aren't going to transition. They may move and be close, but this car needed high quality surface data. We were going to cut and splash molds from this data, so we needed a high level of integrity. So I choose to modify the big slabs and then do the filleting and the busy work over manually. That's just how I use the tool. Okay. So the next part I'm going to work on, if we turn these guys off, is just this little kind of form, I guess. This was actually, it's kind of weird, but it was like a seat cushion. So let me set my layer symmetry up. So to get that layer symmetry correct, right, I would say layer symmetry, set the plane, zoom out, grab this pointer, stick it right there and say set the plane, and now I've set my symmetry plane. Pretty basic stuff. So this was kind of a weird seat cushion. It had these little pods, and your controls, you know, this would be the bottom. Your controls and things were just setting on that surface right there. Okay. What ended up happening with this, the designer wanted to just continually modify the size and shape of this area. So where all of these surfaces kind of gravitated towards, they kept wanting to shrink it in size, move it up, move it down, and it was kind of a pain to continually reblend all these surfaces. These surfaces, this isn't a Class A model, but these surfaces are, as you can see here by their CV structure, they're pretty nice surfaces. Okay, I'm just going to go to hardware shading mode. Okay, so they're not pretty clean, and I was looking for an easy way to move this guy around. So an easy method for that is to use, again, a predefined modifier. So let's say I wanted all of these surfaces to transition and now touch this surface instead of this surface. Okay, so we're kind of getting smaller, maybe shrinking in size, so on and so forth. Okay, so that's what we're going to do. We're going to select the data that we want to modify. Hopefully I'm not going too fast for everyone. Actually, I'll try to slow down a little bit. I apologize. I know that there's people from different countries and things, so I may have been speaking a little too quickly. So I have the data selected that I want to modify. Accept those targets. Okay. Now it's just waiting for me right now and saying, what do you want to do? How are we going to modify this? Well, up here it's saying press a free and a predefined to add modifiers. So I'm going to add a predefined modifier, and I'm going to go from here, accept, to here, accept. So you can see, again, how it's drawing the little visualization lines that show me how it's going to shrink this stuff. So think of it as like a volume, and it's just going to squish it down, okay, and in, and rotate it, and do all these things to it. Okay, so I'm going to say go, and it does it. I mean, it does it so fast you kind of can't see it, but it now, instead of following this perimeter, right, it follows this perimeter. Okay, but I've lost some things, right? I've now lost this continuity over here, so I've got a big tear in my surface. Okay, that means we need to use a constraint. So I'm going to go back over to the Transformer Rig Tools. I kind of like to open this too while I'm working. Once I've got it established, you can Shift key and hit the box, and it will open it. And I'm going to add some constraints. So constraints are data that, while it's modifying it, you want to maintain continuity to. and you can only maintain position or tangent, and I'm going to select tangent. Okay, and then I just tell it I want you to be tangent to these surrounding patches. Okay, get those selected and say accept. You can see it says tangent to those surfaces, and I'm just going to say go. Now, just to clarify, these are all trim edges. All right, this is a square surface with a trim edge. So we'll hit go. Okay, so now it's gone from this surface down towards this surface. It's stretched all those guys, pulled some back, and maintained continuity. And if we look at our control structure on these surfaces, I'll just do a pick nothing. And let's just grab these by surface. We'll just grab some of them just to look at the CV structure. It hasn't really destroyed the CV structure. It still looks quite nice. Okay. So now I'm going to go in and check for some continuity because we asked for tangency across here. I just want to see. And it's missed it a little bit. 0.3. Here it's missed it by 0.3. You got 1 degree here. That's not good. 1.5. That's not good. Okay. Now I'm not guaranteeing that this can do a perfect job because it's not. It's a starting point. You know, you're getting a set of surfaces modified to then fine-tune. But if we query edit this guy, so that's under Object Edit, Query Edit if you're fairly new to the software. Okay, now I've got the history open for this. I'm going to Shift key and click on this guy, and I'm going to tell this, okay, here's what I'd like you to do. Try a different fitting method. So it has a way of modifying the surface data, right? It's like the brains of it. It has two different systems, an explicit system and an adaptive system. So I'm going to say, well, let's go to the adaptive mode and try that fitter. Okay, by doing that, we've now gotten from, if I switch back, okay, and I can turn auto update on here. Auto update means whatever changes I make will be continually updated. So in the whole mode, we get 1.5 degrees issue between here. In the accurate mode, okay, if you notice, we still have clean surfaces. It hasn't increased the order, which it's allowed to do. It can increase and add data. Hull means it will keep the data the same and not add data. Accurate means if it feels it has to, it will. In this case, we've made a modification that it's kind of okay with. And it's gone from 1.5 degrees in tangency and 0.83 and 0.36, whatever, 0.3 over here. It's gone to 0.36 and 1.12. So now we have very little cleanup to do. And actually, if it's just, you know, it's a seat, so they'll probably mill it out of foam, or it will be covered in something. You know, if it's this was for a concept, so you know, there's some areas where maybe you don't have to have perfect Class A surface. Okay. Now, the next thing I'd like to show is that even once I've done that, if I can take this surface and template it. If I grab this surface now and I move it, I can move that surface up. And as I move that surface up, it you know, you can see that the data changes. So there is a little lag. It's not too bad. Okay, I can't you know, make the thing jump around, but it won't dance. But it can work pretty good. Then we could rotate. I'm having a little trouble with my menu right now. I'll just use rotate from over here. I could rotate that guy. So like when I'm looking at this as a surface modeler, I see this kind of backing up on itself, and if I don't want a negative in this corner or a hollow spot right here, you can kind of see in the shading that there's a little bit of a hollow spot. I might, you know, speaking with the designer, I might go, hey, what if we rotate this just a little bit, and then maybe in the Z just a little bit, we can kind of get this negative out of here. Okay, now we don't have quite such a bad spot in it. It's a way of modifying all those surfaces, because it could take a while to rebuild all that data. You know, and in this method here, we have basically used existing data and modified it. and again using the predefined modifier. You could use a free modifier, which a free modifier would just be, it would basically be, and that's why I didn't show it, it would basically be like picking this surface, or well, the templated surface originally, and then starting to modify that surface because it's a free modifier. So basically you're attaching things to it, and then as you modify that one surface, it all will pull around. Another thing I could do here is scale. So I've got its pivot point set in the center, so I could scale this down, and you can see all the stuff follows it. And you know, the tangency gets better and worse as you make crazier modifications. Again, I'm not going to sell this as, well, sell is a bad word. I'm not going to show this and say, hey, this modifies your data and it's perfect. That's not the case. You should always check the data after you've modified it using any tool, right? Okay. So let me check the time here really quick. Oh, that was 20 minutes, so we sped right through that one. Good. Now I'd like to do a little bit different, maybe a scan modification. So here we have a piece of scan data. And what can happen a lot, you know, I thought after 20 years we'd be getting away from scanning models and surfacing them, but it turns out even after 20 years of modeling, I'm still surfacing to scan data, and we're still scanning cars, and we're actually developing more technology to scan cars and more technology to use the scans for milling. Then you get into Maya modeling or Mudbox modeling or any of these other products that model in polygons. So I think not being one-dimensional and not always having to work in surface modeling is a good idea to get into. And that's where I'd like to show the tool here. Now, I have gone in and made a set of surfaces for this. So, you know, we had a scan. I went in and surfaced that scan, and we've got a nice set of patches here. You know, you can see pretty nice continuity, a nice washout. Let me just get a different shader on here. Maybe, yeah, Shady Sky's fine. Turn off the patch line so you can see. You know, yeah, you can surface model this. It's got a nice fade out right here. It looks pretty nice. But a lot of times, if it's a show car or something up front, or even if it's not, if it's just a simple modification that they're asking for, oftentimes I think that they'll just say, hey, you know what, we did the model, here it is in the side view, it doesn't have enough power dome, engine, the engine isn't puffy enough, it doesn't look strong enough. And in this case, actually, when I look at this, I kind of see that it's got nice acceleration, and then it kind of flattens out at the end. So if I just look at this surface right now, and we turn some curvature combs on this guy, and I'll just up their scale a bit. It is still accelerating at the front, but maybe they want it to, maybe the designer or the person, or maybe I wanted it to be more accelerated all the way across. Okay. But let's say they whoever is asking for this data says, yeah, you got about 20 minutes to rebuild that hood, and we need it to come back to 0 at this fender because we love the side of the fender. So we want you to puff up this area and vanish it to nothing along this edge because we don't want to change the fender, and we're just going to pack some clay, and then we're going to quickly mill using Tebas. We're going to mill the polygons, so we don't even care if you surface it, just whatever. Okay. First thing I'm going to do is duplicate this center curve just so we can know where we were. Okay. Then using some quick modeling tools here, let's grab the CVs on this surface, and let's just say, you know, I'm going to turn the diagnostic off for a second. It's just in my way. I'm going to add some acceleration, and I'm going to go into ortho mode because I don't like to see the tapering perspective of the CVs and holes. If I was looking at shape, I'd be in perspective mode. In this, I'm better, I guess, at analyzing curvature by looking at the CV layout. So I like to be in ortho mode so I can actually see where the CVs are. Or more precisely, I guess, is how I would phrase that. And I'm going to add some acceleration up at the front. I might even slide a row here to get some more acceleration. Let's try this guy too a little bit. Bring his friend along and add a little more acceleration over here. Okay. Now, so what I'm doing right now is setting up a predefined modifier. Now, what mistake did I just make? I just modified that surface. I copied the curve, and I didn't keep the original surface. And I like to have a predefined modifier. I need one right now. So I need to get that surface back. So, my mistake, but it's a good thing we save all the time. How often do you save? What don't you want to do over again? That's my rule. So I'm just going to copy that piece of data and paste it back in here so I can have my predefined modifier. Okay, I need to come back to 0 over here. So I'm going to duplicate this edge. Okay, and just so you can see this frame that I'm going to set up, I'm going to shut the STL file off. Okay, and I'm going to delete, or maybe I can just turn off. Okay, so I want to be 0 here. So I'm going to go surface skin and make a surface from here to here. Now I've got the modified portion, and I'm going to go from there back to the same curve with the skin. Okay, delete locators. So now I have a before and an after. I'm adding crown to the front end, but I'm coming back to the same fender. Now, one thing that I like to do here, it can use multiple surfaces as a predefined modifier. You could have 3 surfaces or 4. I would never suggest going from 3 to 4 on your modifier. You want the same CVs on each patch, because what it's doing is, if we look at this, you know, when we're seeing that clamp resolution or sampling resolution where it's showing the little green lines, basically it's going to move the data under here in a direction from this point to that point. And however they're moved, that's how it's going to modify. So if there's 0 movement at the front right here, the underlying data shouldn't move right there. Okay. So back here at the back, no movement. The lead in at the back, no movement. All the movement's just going to happen basically in this CV area. Okay. And then it's going to taper to nothing in this area, right? So what might I do here to make this a little easier? Well, what I would suggest, we've got an order 5 there and an order 6 here. I'm just going to rebuild this to 5. Okay, it says it deviates 0.01. That's okay. 0.01 millimeters. That's fine in this case. We're asking for a global movement. Okay, so now I'm going to make these into one surface, and I'm going to do that using the Object Edit, Attach, Connect. The only way I use this is if this surface's edge and this surface's edge are coincident. So these CVs were already right on top of one another. That is a good time to attach them. There's a break in the surface, but I'm just making one surface out of it. And then I'm going to do the same on the top. This guy and his friend. Okay. So now I've got my before and after. If we cut some sections just to show what this might look like. Where'd my section tool go? It's not popping up. Interesting. Well, let's look at the curvature combs then. You can see the difference in curvature combs, right? At the front, we got a little point in the beginning. Now we don't. If we turn the other guy on, okay, now we've got different acceleration, right? We've got more acceleration at the front and the middle. We've got a little low spot right there. So I'm going to do a couple little modifications here just to try to fix that stuff. So one thing that I'm going to do is maybe move this CV and this guy up a little bit. There. So now it's not so hollow in the front. Maybe I'll move this guy too, because this outer edge, see this cone slopes down. So we can move that guy a little bit. Let's just say that's good. You could tune these to your heart's desire. Okay, so I get my predefined modifier set up. And I'm spending a little time on that because that's the critical thing in using a predefined modifier. Being sure that the before and after patch have the same CV structure and that the movement happens in a direction that you want. Okay, and I'll explain that again in the next demo. I'm going to turn the STL file on now, and let's just take a look here at what we can do. I want to modify the STL data. I'm going to turn its shading off. Accept that as the target. I'm going to use a predefined modifier, and I would like to select this gentleman here. Accept that. Going to this gentleman, and there we go. It's modified it. Okay. So if I turn off the surface data now, it's now puffed that surface up and it's got a lot more crown across the front. Now, what's an easy way to see? Oh, how can we see what this does? Oh, I know. Quickly, if you want to see an end result, you can delete the construction history, and that will dump off a templated version. So now, if I turn the symmetry off, you can see I have a template. Well, maybe you can't as easy as I can, but I've got a templated version here. Let me turn the transparency down for meshes. Okay, so you can see I've got the templated version lying underneath it right there. So I'll just pick it and untemplate it. I'm going to then assign it to its own little layer, turn symmetry on. Let's turn the mesh density, mesh transparency back up. And now you can see I'll use ISO angle, and you know what? Let's turn the ISO angle. So ISO angle, black and white bars, they're two different analysis tools. So I'm going to pick that and just up the number of repeats a little bit so we can just have a little better look. I like the blur up just a little bit. Okay, so previously, right, this was our hood. Now we have this hood, and it's done. All of this transition in the corner is all moved. You know, it's all moved around. So, and it comes back to 0 along this edge. I've got to figure out why the sections didn't work. I think it might be the menu might be appearing somewhere that I can't see it. Let's just use dynamic section since I can't. Oh, there it is. I was right. It's hidden behind my little go-to thing. So I'm going to cut cross sections, okay, just so you can see how this thing, what it's kind of done. So, right, it's grabbed all of this stuff and just brought it up based on those surfaces, and it tapers back to 0. Okay, and you can see back here at the back corner we have barely any movement. So, you know, is there a little difference right here? Sure. That was outside, though, of our zone of control, right? So stuff back here, that could be off. But if we look right here where we are governing it, there's very, very little difference in data right here. You got 1, 2, you see very little movement right there. Okay, so that's a way to get a nice global change in polygonal data versus modifying the surface data. You could use the same technique with the surface model. In this case, I just showed how to use it on clay, because maybe you didn't have a full surface model. You could model one curve right here. You could model one big patch in the middle that's close to surface without doing all these transitions and everything, because all of the work is in doing all of this, you know, all of the tapering and transitional stuff that's in here. Yep. You know, doing all of this, you know, vanishing of this fillet, that's all the work. So if you can get away without surfacing that, that's better. Okay. Next, we're moving right along. Yep. The next demonstration is another, I guess, another predefined modifier. So this was a grill for a show car. Let me turn on some shading so we can see what this looked like. Okay, so we set up a nice, in the front view, we set up a nice layout of these grill pockets. This was a front grill. And these grill pieces were going to be, I think it was going to be paint across to here, and then this step was going to be a little step for an aluminum insert, I believe, that was in here. And then we had to surface each one of these that got progressively smaller. Okay. Now, I surfaced all of this one, and then, you know, thought I was done. Management or other people came in and looked at it, checked it out, and decided, nope, that's way too many. We want to go from that to something more, and I don't have the sketch, but we only want, if this is the front fascia, let me turn on these multicolors. We really want, instead of this giant layout with, I'll show it on the other side, instead of, you know, 1, 2, 3, 4 by 5, instead of 20, we only want 4 by 2. So, but we really like the section quality, the angle of the surface, the little step for the aluminum. So just reproduce all that stuff with the same radii in the corners, the same everything, and that would make us happy. Okay, so how do we do that quickly? Because they want to just see what it looks like, and this was, again, for a show car, so it was something that I wanted to have done, you know, as fast as possible. Well, there's a few things to note. This was my base surface data, and unfortunately, with the sketch that I got, because these modify patches are over top of the sketch, you know, I just created little patches to use as my before and after predefined modifiers. Okay, but I needed those to be one patch because I don't like using two, especially if the original didn't have two. And the original, the reference patch, is going to be one of these guys. Right? The original patch is going to be this surface. So what I did here is I took the original grill, okay, and I trim converted a little piece that was the outer periphery. Okay, so basically grabbed the slabs and made a patch by trim converting this original face. Okay. Then what I did is I made one patch. So pick. I made one patch over top of all of these patches in this area. So basically, these sets of surfaces are just sitting right on top of one another. But I made one that's sitting right there. It's close. I don't know how close we could analyze it, but it's close. It needs to be as close as you want to be accurate with the leading edge of this part that we're going to modify. And I'll keep explaining as we go. I think it will soon make sense. So the first thing I needed to do was basically create a patch that covers the area that I need my modifications to work in. Okay, so I've done that with this base patch. All right. Object display visible. Okay. Once I got that patch, then I could trim convert in the front view. I'm not going to go through trim convert, but it's pretty easy, right? Then I go in the front view and project my set of curves on and trim convert and get these little individual patches, okay, from the original. So these sit right on that patch, okay, on the base. Now what I have is a predefined modifier that I've set up, right? Here's an original surface that was based on the fascia. Here's the new angle and attitude I want that surface to be. Notice that now I'm going to get into a little bit more of the nuts and bolts, I guess, of this. The U and the V direction have to be the same. Otherwise, it will flip and turn inside out the data if the U and the V directions are not the same. Okay, and you modify the U and the V directions under the reverse surface U and V, right? Okay. So once you get the U and the V all corrected on all these patches, next thing I want you to notice, see the even layout? Okay. I'm going to break one of these just to show you what wouldn't work. If my resultant trim converted patch had a surface layout that looked, and I'm not really going to make it horrible, but let's just say these CVs, I'm going to turn my mouse sensitivity down a little bit. All of these rows, let's just say they're biased, because a lot of times people will move CVs toward, and they correctly do so, move the control vertices towards the area of more curvature, okay? So if that's your resultant surface, what's going to happen is this data, when it gets moved over, because under this, right, if I template this guy, underneath here, this is kind of a little symmetrical piece, right? The radii are fairly consistent. This thickness is one thickness. This is about the same thickness, as it goes around. If I take a patch that is even and I squish it to one side, it's basically like non-proportionally scaling that data as you move it. So what it's going to do is it's going to make this side thinner and this side thicker. So it's going to stretch this way because this CV structure is wider than the original CV structure here. Hopefully that makes sense. It's difficult for me to read the room when I can't see. But you need the same kind of layout of these CVs. So what you can do if you do end up getting this kind of structure is just try to reorganize these CVs so they look basically the same as this. And I know that sounds hard, but it's, we're roughing some things in. We want to quickly move this stuff. So you can't be so nitpicky on, when we are done with this, if this edge is 1.25 millimeters, it's probably not going to be 1.25 millimeters once we modify it. The draft, if it's got draft, it's not going to maintain draft. All it's doing is modifying the data based on a volume. If you're looking for perfect, finished data, this probably isn't the tool for you to use because it can't take all of that knowledge that you baked into that surface and simply transfer it really quickly. It doesn't have that knowledge in the tool to know keep draft, keep minimum radii, keep all these things. I think it's a little unrealistic to expect that kind of result, I would say. But for rapid surface modification and for getting, some data you can visualize or mill really quickly to see if it's going to even look right, that is what this is good at. Okay, so once you get your before and after patches laid out, then we can start to modify the data. Okay. What I like to do is move this data as close to where it's going to be used as possible. So I would just take this guy, and in the front view, I'm going to move it down and inside of here. Okay, and then I'll swivel around to this side, and I'm going to move it forward. Okay. So I try to, if you make the thing try to do something crazy or more complex, the solution is more complex. So if you can simplify things a little bit, I think it's beneficial. So I'm going to copy and paste that data, stick it on a new layer and move it over and back. Paste it, move it over, move it back. And again, I'm just getting these close. It would work if you did it from the original location up in the corner. Okay. If it was over here, it would still work. I find I just get a little bit better results if we do this in this fashion. So now what am I going to do? Let's go into the dynamic shape modeling tool, transformer rig. What do you want to modify? Well, I don't want to pick it, by each little thing. So I'm just going to box it and then deselect these two with the right mouse button. Okay, that's how I have my selection set up. Accept those targets, predefined modifier, go from here to here. America. Did it. Okay. You can see the stretching things. If we look in the front view, it's got a really similar shape. Okay. Next. Oh, this guy. Deselect. Okay. Predefined modifier from here to here. Oops, I accidentally hit the two, the modifiers as the same data. So that guy from here, predefined from here, except to here. There he goes. Next. Move this guy. Shift key. Predefined modifier from here to here. Okay? So now you can just, drive around. I'm not going to do all of them. I'm only trying to show I'm just trying to show the concept of what I'm doing, not all the finished results. So I'm not going to go through the whole process of trimming and doing all that stuff. But that's how you can quickly modify those grill pieces, and you can easily get something that you can shade quickly and show people. Then if they buy into that design, maybe you can request a little more time to fine-tune the data. And again, I could check this for continuity. I don't know. Maybe it's good. Maybe it has messed some things up. I'm not sure. Let's check a few of them. So, okay, you get point 1, a little bit 0.42. Okay, you get a couple things off, but I think you, well, hopefully you see my point. Okay, so looks like we have about 10 minutes. I wanted to have time for questions. So I think we should do that now.
Hi everyone. We weren't really expecting time for questions at the end, but obviously we have some time for that now. So if you do have any questions, Barry is on hand to answer those.
I think it was perfectly described, so no one has any questions. Just kidding.
It must be that, yeah. Actually, while we're waiting for some questions, is there anything else that you can show us around?
Geez. Sure. Maybe not dynamic shape modeling. That was all I had. That was all I had brought for dynamic shape modeling. Let me. I did do a short thing last. Well, it was at Autodesk University. I didn't. I didn't go, but a colleague did the presentation, and I might be able to do some of that. I could talk about some curvature diagnostics. How about that? Does that sound okay?
We could do that, or actually we have a few questions come in now, so we could go straight to questions.
Sure.
Okay. The first one is, Are these tools only available in automotive?
Oh, I'm running automotive. I'm more of a technical person. I'm not sure that all the transformer tools are available in the lower products like design. I think in Surface it's available, but that's not, I can't. So the question was, Owen, can they hear your question?
Yeah, the question was whether the tools that you've just demonstrated are only available in the automotive application.
Okay, yeah, I can't answer that. I could get that answer, but I don't want to say for sure they're available in design because I'm not positive.
Okay, we should say actually that there will be some contact details, so if anybody kind of wants to expand on these questions afterwards, or I'm sure we can get back to people with
Sure.
The next question is, can you use multiple surfaces as constraints, and is there a limit to how many?
Yes, you can use multiple surfaces as constraints. Geez, I don't believe there's a limit. I've never reached it. And I would say over-constraining might not be the best idea. But, you know, when I did the seat, we had about, whatever, eight constraints. So, you know, it's at least 8, but I bet I've used more than that. Yeah, you can use multiple surfaces like I did. And you do only get options for curvature and or position and tangent. Curvature is not available. So, yes, you can use multiple.
Okay, the next one actually isn't so much of a technical question, it's more a question about actually generally being a professional modeler. Do you think that it's necessary to have design knowledge in order to become a professional modeler?
For sure. Yes, that's critical because you need to know the questions to ask, right? So you need to understand the language that the design community uses. You know, they'll use phrasing like tension in the surface, or you know, the surface is too gooey, or it's too muddy. You know, so you need to yeah, you need to have that knowledge, and the more knowledge you can have, which obviously you can gain from experience, it just helps you to talk with all the people in the design community. I think, and actually that was a big topic that I just was supposed to cover at AU and kind of did. I think as a professional modeler, so as a Class A surface person that works in a studio, you are the communicator between the sketching designers and the engineers and the suppliers. That job, the better modelers can do that job well. So that comes right down to taking notes, and I don't know if I have all this, but I'm just going to look for it really quick while we're here so people can watch me browse around. I thought I had a little bit of information about that, but so sketching tools, using the sketching tools inside the Alias product, I just use them for demonstrating to people what I'm thinking of doing. I'm not a sketch person, so I can't do that. But some things that I do, here's an example. I think it's our job to, I don't make this 100% or something. Fit to window? I don't know. Okay. Like these are notes that I took. So you need to get in there if you're the person about knowing about design, you know, or things. As a Class A surface person, you need to know about all these. Ask these kind of questions. What degree does this need to be? What are all of these offsets? This is how you communicate to a designer when the supplier says, this is the supplier's drawing, right? This is my drawing, even more detailed than the supplier's drawing. I need to then go back to the designer and say, you know what? You can't make this as thin as you want. You only want this to be 10 millimeters wide, but they need 8 plus clearance plus material plus draft. The minimum you can be right here is 15. Okay, and your ability to communicate that stuff is I think, at least 50% of the job, if not more. So a great question, and yeah, you need as much design knowledge as you can, as much paper drafting and sketching. I'm no artist by any means, so all I mean by sketching, if you're a surface modeler, is stuff like this so you can basically communicate between people. That's a big portion of your job. I did find out too that the advanced dynamic shape modeling tools are not available in design. It's all the T-rig stuff is in surface and in automotive, but design only has the lattice rig, so a more global way to modify things. Okay, so there we go.
Great, thank you.
Sure.
Another question which is more technical than the previous one. You said that 0.3 and below is enough for tangency continuity. Is that enough for prototyping? And for A-class servicing, would it be 0.0 curvature continuity?
Good question. Maybe I should clarify if I said that, and we have it recorded, so I think we can go back and see. I think all I meant was it's good enough. It's good enough out of the tool, I guess is what I meant to say. I would definitely go back and fix those tangency issues. So anything under 0.1 or 6 minutes, I don't let go by. So I was more speaking figuratively of the dynamic shape modeling tool. That's as good as it can do. I would go back and fine-tune that by hand with some CV modification tools and tune that up beforehand. It is not good enough for Class A. Generally, Class A is 0.1 degrees for tangency and 6 minutes if you're, some people use the different terminology. I even like to get it closer than that if possible, because in certain areas that can still be not good enough. And obviously curvature, yes. Can't always have curvature of perfect curvature, because if you have a 2 millimeter radius, how can it be curvature continuous to a relatively flat plane? So the curvature is a more interesting topic and takes longer to discuss than I think we have right now. But yes, not good enough for Class A. Good enough for prototyping, though. The prototyping tools, because usually what you're doing is dumping out an STL file, and those don't really care. So you can have hard edges in those, and they can be prototyped. So yeah, it would be okay for that. Sure. Okay.
Great. Andreas has asked us a question. He said it was a great session. Kind of new to this software. Are there going to be any beginners sessions? I think we can probably answer that, and that hopefully yes, there will be some more Autodesk webinars, and maybe that's something that we can think about doing, some kind of looking back at the basics. So we'll definitely look at that. Next one is from Tommaso. Hello Barry, I'm your fan. In the previous sample, why modify polydata? Isn't my target a nice flowing NURB?
Well, that's kind of what I said. Not always. A lot of places now would rather the quick feedback and response time of simply modifying the polygons. I mean, you have milling equipment, 5-axis milling equipment, 3-axis milling tools. Tebas, I know, does it. A few other, I guess I don't need to mention specific names of softwares, but people can mill polygons. So what I found is, if you can quickly get them the shape, because they're going to mill it in the clay and then clean it anyways to put Dynoc or whatever on it. So sometimes I think it's at least good to have the knowledge that, hey, I could just modify these polygons if you want. I don't need to take the 25 hours to make Class A NURBs if you don't need the NURBs. If we just want to do this for visualization and see what it's going to look like, well, you could do that in polygons, and it's much faster, right? Because you can shade the polygons, you can put reflection maps on them, you can bring them into Autodesk VRED and ray trace them and do things in there. So yeah, I think there's a time and a place to modify polygons. Since I'm a surface modeler, I want to not do that, because my job's to make surface, not modify polygons. But I think as we move forward technology-wise, I would just, I've been preparing myself to be more flexible. I think scanning is going to become even bigger. Rapid prototyping, which only requires STL files, not NURBS, is going to be bigger. So your ability to, work with polygons, I think, is a wise and a good thing to start to get familiar with. Yep. Thanks for being a fan too.
Okay, I think we have time for one more question. Can we use multiple unconnected surfaces as reference and targets? For example, imagine your grill holes, but I want to modify them with another surface at the back side facing the engine.
Yes. Okay, I get the question, and I would. Okay, yes, and I would do that in 2 steps, I guess, is how I would do that. So you can't do. Yeah, you can't stretch it in 2 dimensions at the same time. At least I don't think you can. I've never tried to do that. But you would have to make first the step that I made, and then take your back side patch. You'd have to make the same before and afters and stretch it rearward. So the answer to his question is, even if you could, my answer would be, even if it was possible to do, which I don't think you can set that up. I'm trying to think about it. I don't think that's how you would want to do it. I think you would want to do it in 2 steps instead of trying to do it at the same time. Okay, so the answer isn't really no. I'm not sure exactly how you would set it up, but I wouldn't suggest setting it up that way anyways. Just use 2-step approach. Okay?
Okay, actually, let's have one more. Can you feel a kind of competition between polygon modeling and surface modeling in this sketch modeling first prototyping phase?
So what was the very first beginning? Is there a competition? Is that what I heard?
Yeah, so I guess is there a kind of tension between polygon modeling and surface modeling?
Oh yeah, so tension. I mean, maybe I'm picking up in his phrasing, or I don't know if it's intentional, but yeah, but I don't think there should be tension. I think there may be tension only because surface modelers, theoretically would be losing work if you could polygon model all the upfront stuff. So, yeah, there could be some tension there or polygon modeling people wanting to make movie characters instead of cars or product. But I think just for the future, we've been surface modeling NURBS has been around for years. I've been using NURBS to do surface modeling for 20 years. I just think there's going to be some and this isn't speaking from any internal knowledge, so don't take that. I don't know any, crazy stuff about new modeling tools. But I just think there are becoming more and more tools for polygon modeling. We've got Maya and Mudbox, and I don't even know them all. But I think we should, I don't know if embrace is the right word, but I think as a modeler, I don't just want to be a surface modeler. I want to be a modeler. And if you want me to use, I could model in clay if they wanted me to, but I'd be slow at it and probably not as good as people that they already have. So I think it would be wise to learn how to work more with the polygons and even be interested in it. I am interested in learning more about polygon modeling. I think it's faster at the onset, so maybe even easier than conceptual surface modeling to do your concept modeling in polygons, and it's harder to analyze polygons, right? So it's easy to ask continuity between 2 surfaces. You ask it and it says, and it gives you a number. It's objective. It's not subjective. It's a objective analysis where it's either good or bad. That's with surface modeling. In polygon modeling, there's a lot more flexibility. So I'm kind of thinking of embracing that and letting myself be a little freer, I guess, as a modeler, where I'm not constrained by having these, 0.001 gap checks and all these things. It's polygons. If it looks how you want it to look, it's correct. So there's a total difference there. So tension, I don't know, maybe. I just think as a modeler, if you want to be a person doing modeling of any kind, you should kind of embrace polygon modeling, learn how to work with polygons and Alias, and even learn other products, because I think in the future, with as much as I see in the rapid prototyping field, and all it needs is polygons, I think that will drive some of the modeling tools to make polygons and make it easier to use. Okay?
Great. Well, thank you very much, Barry. Really fascinating insight, and I think you've made a couple of new fans today. Please remember, everybody, that this webinar is going to be uploaded onto the Car Design News archives, and it's available to anyone who wants to view it at a later date, so either yourselves if you want to see it again, or any of your colleagues. You can access this and all the previous webinars under the Processes tab on the Car Design News homepage. Thank you again. Please don't forget to join us all again in the new year for the next car design webinar. Thank you. Goodbye.
Thanks, everyone.